My name is Eric Groves, and today we'll be discussing the process of developing object-oriented systems. We'll be discussing the system development lifecycle as well as development methodologies and how these fit into object-oriented system design. So first, let's go ahead and talk about why do we need a process. The first thing to consider is that there necessarily isn't a right way or a canon way to really develop a system. For example, you may be developing an accounting software system. Well, looking at a system that was developed for controlling a power grid probably wouldn't necessarily give a lot of insight into how that was done. The processes taken will most likely be unique across each system developed. Another thing to consider is the complexity, especially of object-oriented systems. A process really helps deal with that complexity. If you're working with a system that's going to have dozens or hundreds of objects and classes as well as subsystems in multiple geographic locations, you're going to want to have a process to deal with that complexity. Another thing it really does is provide structure. It gives a foundation really for team members, stakeholders to really know what's being done at this stage, what's being done here, how did we get there, what did we do. It provides that level of structure to really better meet requirements, which is the ultimate goal. So let's go ahead and talk about the system development lifecycle. Harry Rosenblatt describes this as activities and functions that developers typically perform when developing a software system. Jane and Jane further this definition by saying that it provides structure for team members and stakeholders. And at the bottom here I have made a very generalized version of the SDLC. The SDLC will typically take many forms depending on the methodology used, but what I've tried to capture here is just a very generalized look at what an SDLC looks like. So you can see by that diagram it provides a level of visibility and predictability at every stage. You can see this is what we're doing at this stage, this is what we'll do at the next stage. It gives that predictability that's really very valuable when developing a system. So next, let's talk about development methodologies in depth. This is really one of the first things you're going to want to determine when building a software system is what methodology will I use. That is really going to set the direction of the project as well as really how you're going to go about developing it. And most methodologies fall in two categories, either plan-driven or agile. Plan-driven is really a more traditional way of building a software system. It focuses on going step by step, having well-defined goals to get to each step. It's very structured. Agile focuses more on getting a working version out as soon as possible. It's prototyping. You build one system as soon as possible. If that one doesn't meet requirements, you roll back, build on what it did good, improve what it did bad, and you keep doing that until you build a system that meets requirements. And typically a method will not be purely one or the other, but it is important to know what side the methodology you're using is leaning towards. So now let's go more in depth into plan-driven development. On the right here I have a waterfall model diagram, which is a plan-driven methodology, and really it looks fairly similar to the one that I presented earlier. It goes from one step to the other with strictly defined goals, and basically when all the goals are met for one step, then it moves to the next step, never before, and it never really plans on going back to earlier steps. And so these are typically best for large and complex projects. If you have a project that's going to have a very large scope, multiple departments, multiple geographical locations, tons of objects, classes, subsystems, things like that, you're really going to want that structure to organize all of the complexity of that large project. And also with large projects comes large teams. And it's going to be very important to assess the skill of each team member to know where they fit into the development plan. And so with this step-by-step procedure, you get a predictability and level of stability, which is always very important. Peterson and Wolin describe the main reason that plan-driven development methodologies fail is because of lack of clear requirements. Now, This is why they recommend that requirements be strongly managed, because you need to have those well-defined goals to effectively move from stage to stage. Now let's talk about agile development. On the right here I have an incremental / iterative model diagram, which here you can see it's very different from the previous ones, and you can see where it builds one system, it'll roll back to the next to build the second system until it gets it right. It focuses on making working versions, prototypes of the system to ultimately get that final version out. And this is best for small projects, because if you're dealing with a very large scoped project, you might end up wasting more time trying to do it agilely than you would if you just tried to follow a structural method. Highly skilled team members are very necessary, because you're going to have a smaller team. You're going to want to make sure that each member has a wide set of skills, because it's most likely multiple team members are going to be working on multiple things. They're not going to have necessarily set responsibilities. Everyone's going to be working on different things at different stages. And agile development really has a large emphasis on user involvement. Because each has those iterations, user feedback, user testing is very important to determine what do we need to improve in the next iteration. And Peterson and Wolin say that because the iteration lengths are so short, it really does facilitate better communication. Users are going to be more involved than they would be in a plan-driven method. So now the question is raised, which is better for object-oriented design? Really, it works well with both. Harry Rosenblatt describes plan-driven methods as providing extensive enough information to really help with plan-driven methods. The models that we'll be talking about later really give valuable information, documentation, and helps provide clear goals that is really necessary for plan-driven methods. He also describes it as flexible enough for agile methods. Classes and objects can be easily added and removed to meet with new iteration requirements, as well as adding new software and things like that. It can very easily adapt. And the decision between the two really needs to be made during the first phase of the SDLC, the planning and requirements phase, which we will now talk about. So let's go ahead and talk about each phase of the SDLC in more detail. So the first thing you're really going to want to ask is, what problem will the system solve? Because you need to have that understanding of what problem you're solving to really come across with an answer. From that, you can determine the requirements for the system. Based on how they will solve the system, you'll meet with the stakeholders to determine those requirements. Once that has been done, you can perform your preliminary investigation and feasibility test, which during the preliminary investigation is where you're going to determine the scope of the project, really get a clear understanding of the business, how they operate currently, how the system is going to fit into current operations. You're going to assess the IT skills, and also weigh costs and benefits to make sure that this is going to be a meaningful project. And once you have all of that done is when you can determine your development methodology, whether it be plan-driven or agile. The next phase is the analysis and design phase. And Musar and Kavanagh describe this as the phase where you analyze, specify, and define the system, which you do that by identifying the objects and classes that are going to make up the system. By applying ideologies like decomposition, abstraction, and hierarchy, we can better understand how those objects and classes are going to interact with each other to make up the system. Decomposition is dividing the objects and classes into logical clusters. Abstraction is differentiating them to see how they are different. Hierarchy is seeing what classes and what objects are dependent on one another and how that all fits into the scheme of things. The last thing that's very important in the analysis and design phase is unified modeling language and making models using it. And basically what that does is you can model things like the user input on the system, the sequencing of the system. Several things can be modeled inside the object-oriented system using a UML language. And so this really kills three birds with one stone. It provides models for programmers that can be easily transitioned into code. That's one thing UML is designed for. It also gives visual models to present to stakeholders to show this is how we're meeting requirements, this is how the system is going to function. And lastly, it creates a documentation, which is very important at any given time. The next phase we'll talk about is implementation. This is where the system is actually written and tested. Now the testing done here is different from the testing in the next phase. The testing done here is done on a functional level. You do unit testing on individual classes to ensure that they are functioning independently in the way that they are expected to. The next testing that is done is integration testing, which is done in components and groups of classes to make sure that classes are interacting correctly. And the last testing you're going to do is system testing, which is done in the entire system. And the end result is an executable version of the system. So this leads us into the testing. And this is where stakeholders, as well as users, will test the system, make sure are we meeting requirements. Users will perform a user acceptance test to see what the users think about the test, or the system. And then feedback is gathered based on the user feedback as well as the stakeholders to determine if all the requirements have been met. And if that is done, user training can begin to ensure that when the system is ready to be deployed, users already have some knowledge at least of the system, which leads us into the deployment stage, which is where the final project is made available. And the most important thing to worry about in this stage is the transition period. And Harry Rosenblatt describes 4 methods of transitioning, which is direct cutoff, which is where the old system is retired and new one's added. Parallel operations, where both the old and new system are running at the same time until the old one is retired. Pilot operations, where the system is implemented into individual departments or geographical locations until the entire organization is all using the new one. Phased is where individual modules are implemented at different areas of the organization until the entire system is up and running. And direct cutover typically has the lowest cost but most risk. Parallel, highest cost, lowest risk. Pilot, operation, and phase fall somewhere in between. And once that is done, you are ready for the maintenance phase, which is where development more or less stops and the team focuses to maintaining, protecting, and enhancing the current system. This means correcting errors that may come up, adapting to changes in the business, such as if new software is introduced, making sure it works well with the system, and making sure security controls are implemented to protect the system. And so let's go ahead and do a quick wrap up. We talked about why we need a process, which is to deal with the complexity of the system and to set up the structure necessary to meet requirements. We talked about the system development lifecycle, which is the actions taken typically to develop a system. We talked about development methodologies such as plan-driven and agile methods. And we talked about the individual phases of the SDLC and how they interacted with the object-oriented paradigm. Here are the references that I used during my presentation. Thank you for viewing, and I hope you enjoyed it.